So here is problem number 19 from section 4.4 in our calculus book. The idea is that we're going to make a suitcase by taking this template here and putting it twice on this sheet of paper. So if you can imagine, we're going to put this template here, and then we're going to do that template again. And when we do that and take out these corners, we get this shape right there. That shape then folds. Oh no, sorry. It folds where all the light dotted lines are, and this becomes the bottom, this becomes the top, and then these two pieces come together to form one of the sides. These two pieces form the other side. Yeah.
Doesn't that base area, wouldn't that become the bottom?
Oh, I'm sorry.
It doesn't matter. It's either way.
Okay, sorry. This becomes the right-hand side. Sorry, left-hand side. This becomes the right-hand side.
There we go.
Fold up. All right?
Well, one of the
These two pieces form the top. They fold over the top. All right. So, knowing all that, let's talk about the formula that's going to help. The formula that we're going to take the derivative of to find a maximization or a minimization. Okay, if we take the x's that were given here, this is an x, x, x. This distance here is 2x. All right?
Right.
This distance here has got an x and an x, and it used to be 24 inches, but 24 inches less these two. This distance here is 24 minus 2x. So we've got one side of the base dimension, the other side of the base dimension, and the other dimension is going to be, okay, wait, this comes up.
Is kind of thing gonna be
The
on
book said
exam?
18 minus 2x, but I don't know how they got that.
Because of original template is 18.
Oh, okay, but how does that? Because that's not how big that's not the width at all.
Okay, so this, oh, is it this side right here? Let me do it in a different color. This side right there is going to be the height of the box. So here's our two base dimensions, and here's the height.
Okay.
All right? And what do we have for that height? Well, we know that this is 36 inches, and this piece is doubled there. How about I break that into two?
And then
So this is 18 inches, and then 18 minus this x and that x.
oh, there it is.
So our third dimension is 18 minus 2x. So we have a volume equation which is made up of the two base dimensions and then the height dimension, which is 18 minus 2x. And there's part one. Okay, find the domain for V.
Why did you cut it in half? So that's 18 minus 2x.
Because otherwise, if I do 36, it's 36 minus this x and x here and x here and x here minus 4, and I've got two of those, and I didn't feel like having to say, essentially, 36 is equal to 4x plus this unknown y, and then solving for y.
But how
Oh, sorry, but there's two of those y's.
But how are you
Here's one y. Here's that other unknown side, and I just kind of say, well, you know, I know it's symmetric. I'm cutting it in half,
Why
and
can't
so
you just say 4x? 36 minus 4. 36 minus 4x.
because 36 is all of this. That would have counted this thing twice.
You're still gonna get an equivalent equation.
Yeah,
If you divide by 2, you get 18 minus 2x.
yeah. It's a matter of. I thought it looked easier to break it into two and exploit the symmetry.
Yeah, yeah.
All right. So there's our dimension. What value values of x make sense in this? Well, I'm going to say that x certainly has to be greater than or equal to 0.
Yeah, you can't have.
But what's the largest value that would make sense? Well, I'm going to look at this part here, and I'm going to say, you know what? If x is bigger than 9, all of a sudden I'm getting a negative value out of that dimension, and that certainly wouldn't make sense.
Right. So, 9 less than 9. Less than 9.
So I'm going to say that x has got to be between 0 and 9 because, mostly because I can't have negative dimensions in these three quantities.
It can't be equal to 9 then, can it?
Well, it can't,
Yeah,
you
'cause
can
it
make
makes
an argument that it
the
really can't
volume
be
would
equal
be
to
0.
0 either.
Yeah, that's what I'm saying. So it's
Volume
So
would
just
be 0.
less
Less
than 9?
than
Less
9,
than 9 and greater than 0.
greater than 0, sure.
But
All right.
then couldn't it?
Use a graphical method to find the maximum volume and the x for which it gives. All right. In that instance, what I'm going to do is I'm going to go ahead and there we go. What I'll do is they're actually asking a question that you guys asked, I think, yesterday, and that is, can't I just graph the volume equation and then look for maxes and mins in the volume equation? And the answer is, yeah, you can do that. All right. Quantity, what, 2x? Quantity 24 minus 2x. And quantity 18 minus 2x. Do I have that right from the earlier slide?
Yes.
All right. When I graph that, I get that.
wait.
Now, there is a way for us to get the graphical screen to look better and tell us more, and that is, let's go to the window. Let's set the window with our domain. Hit enter. Then do this with zoom fit. And so this is the graph of
it's so
the volume equation as x changes. When we cut nothing out of those corners, we get a 0 volume. When we cut all the way to 9 inches, we also get a 0 volume. And at this location up here, it's maximized.
Yes.
And I believe under the graphing calculator, we can actually say analyze, please tell me the maximum. And I set my lower and upper bound, and it tells me that the maximum is 1.31 times 10 to the third. So about 1,310 cubic inches.
How did you figure that out?
Just move the
Yes.
decimal.
That's all the 10 is. Why doesn't it just say well that's 310? It would use less use way fewer characters.
If this was an AP exam, we would say 1,309.954, say 955 cubic centimeters, because we needed 3 decimal places. Now again, you could have done that methodology without, and we did it without any calculus.
I don't like the idea of rounding so many decimal places because if it's a story problem, it's so insignificant. Not only is it insignificant, but it's redundant because like the cardboard doesn't have like 0 thickness. Like that, the cardboard's thickness alone would change the 3 decimal places. So it's not only useless, it's okay. It's useful.
Well, no. You're absolutely right. These are idealized models. And just like in other idealized models, they break down when you actually try to do this in real life.
And it'd be fine if it was just calculating, but they're using story problem.
I got no argument. This is idealized. You're totally right. Yeah.
What is the significance of the x value?
The x value is how much of those corners. It's how much of these corners were being cut out. So when x is 0, or really close to 0, those these squares that are being cut out are really, really small. But when x gets as big as 9, the squares that are being cut out essentially take up the whole width. So at the two extremes, either you get a really, really flat box, or on the other extreme, you get a really thin box. So I believe we used the graphical method and found what value of x gives it the maximum volume.
We also did, you forgot to check off, we did B too.
We did B2.
Yeah.
Okay, confirm your results in part C analytically. Now, what does that mean? It means that we're going to use the derivative and the calculus things to say, do we get the same answer? So, let's do some cleanup here. Volume of x is equal to 2x times, and I'm going to expand this out. Oh, great. 24 times 18.
432.
432, I'll take your word for that. 432 minus 48 minus 36 is going to be
Negative 84?
84?
Negative 84?
Negative 84, I'll take your word on that as well, plus 4x squared. And then I'll expand that out one more time, and I'm going to get 964 minus 168x plus
Wait, you get 964, 864.
864. Can't do arithmetic.
It's okay.
What you can do
We're in calculus.
calculus.
It's alright, no, we're in calculus. It's
I'd rather
alright.
be a leader.
So maybe I am like Sheldon.
And the X, and X should all have
Yeah.
X.
Holy moly.
What? Holy moly,
It's under
guacamole.
13 and 14. Mistakes.
You just tried to
Are we done with that?
Yeah, that's it.
Oh, finally. All right. So from here, let's find out what the derivative of this is. 864 minus 336
Yeah, but
x plus 24x squared. Now, from here, we notice that it's a quadratic, and we could use the quadratic formula.
yeah, the quadratic formula sucks.
So if we set this equal to 0, we end up with negative 336 plus or minus the square
Well, you can take
root.
out 24.
Yeah, you
by
can
the
take
way.
out a 24.
Yes,
Yeah,
you
take out
can.
24. That's so much easier.
No way.
So if you take out a 24, tell me what we get.
X squared.
14 for 336.
How much?
X squared, X squared, X squared.
Wait, how about this?
Just start with X
36
squared.
Okay,
minus
x
14.
squared
Minus 14x
minus 14x
Plus
plus
36.
36.
plus 36.
There you go. See, calculus writers do have hearts.
They're just three sizes.
I'm going through my head. Is that factorable? No, it isn't.
No, it is.
Okay, so if you set that equal to 0, x is going to equal to negative b, which is going to be 14 plus or minus the square root of 14 squared minus 4 minus 1, or times 1 times 36, all over 2 times 1. And I have no idea.
I still have like the song that we learned.
One of them
I
is
just remember negative
Go for Pablo the Weasel.
No, it's
Negative b plus or minus the square root. No, 4AC.
Yeah, all we learned.
No!
Okay, so
one of them is root 13 plus 7, and the other one is root 13 minus 7.
She taught me this song.
okay, so we have two roots that come out of quadratics. This one is negative. It's an erroneous solution, or sorry, extraneous solution.
Very nice.
Okay, and so root 13 plus 7. And if we go back to this, I'm going to take that number, second stow, and put it into x1. I'm going to go to a calculator page. and I'm gonna compare x1 to,
Root 13 plus 7.
square root of 13 plus 7.
That's,
Hmm,
oh wait, no, it's the minus 1. That's
it's a
right.
minus 1?
Gotta use the root 13 minus 7.
Why?
Because the
Because
negatives,
that-
the negatives
because-
cancel out.
Because,
Because this isn't
sorry,
in the
I-
domain. This isn't in the domain.
Yeah, 10's not in the domain, so you gotta use the other one. There you go.
well, that's,
Wait,
that's always
wait,
Not in
negative.
the
Neither
domain
is-
either.
Negative, negative.
Maybe
That's
7
not
minus
even
1.
negative.
So negatives cancel out. How do they do
Oh,
that?
did you guys, when you took out the 24, did you swap around the equation?
Oh,
Yeah,
is it? It could
Did you
be.
make
That's
it
what the
negative
equation is,
or-
though.
No, that's correct.
Why is it negative? It's not negative. That's weird.
I think it's negative.
No. Sorry, it was the opposite. That's right. The negative one is the opposite
Oh,
of
it's
square root of
you're right,
13
it has to be
minus
the
7.
opposite of root
Because-
13, not positive 7
Oh,
minus 7.
man.
Okay, so what you're really saying is that the solutions to this quadratic are 7 plus or minus the root 13.
Yes.
Oh yeah, that's what it was. Yep.
Okay?
What's the difference between what we did?
What?
Because it's a
Okay,
subtraction.
if you look at this quadratic, I got 14 plus or minus a square root of stuff, right?
Yes.
Now,
Why did you?
if I look at that and I say, this is the equivalent of 14 over 2 plus or minus the square root of 14 squared is like 196 minus 4 times 36 is 132.
Something that's not.
4.
144. That'd be perfect square.
4 times 36.
4 times 36 is
144. I was
144 over 2.
Then we can take this. Oh, no, we can't. No, we can't do that.
So you subtract.
I don't see a 13 coming out of that.
No, it's because you gotta take the root. So
There's
you
one,
gotta
196 minus 144.
take the square root of
square
4.
roots of 13.
Yes.
And the 2's
Yes.
cancel out.
Yes. That's what he said.
If
Yes.
if you're making a stupid, at this
It's
point, I would
it's
just
two
start
square
with
it's two square roots of
Square root
13.
13.
They take out a 4.
7 minus square root of 13.
Take it up, 4 square root it, you get 2 root 13, cancels down.
The square root of 196 minus 144.
Oh,
so you
excellent.
square root to 19.
Wait, what is that
So
number
then the
right
2's
now?
cancel
What is
out.
the number?
Wait, hold-
With 3 over
Even I have 26.
That's
This is
not
so
too bad.
silly.
His
What's the directions problem?
Let's just.
Oh, wait, it wouldn't be 26, it'd be 50.
Okay, so this ends up being the square root of 52
There
over
it
2.
is. Yes.
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 Okay, 52,
It has to be
52 has a 4 in it.
Yes.
So you pull the 4 out, it becomes a 2, the 2's cancel, and you end up with 7 plus or minus the square root of 13.
Yes.
Yay.
Correct.
Alright, now, these two numbers, 7 plus, okay, the square root of 13 is between 3 and 4, right?
Yeah.
So 7 plus a number between 3 and 4 is a number between 10 and 11. But 10 and 11 isn't in the domain of this particular this problem.
Yes.
So 7 minus square root of 13, which is 3.3 something,
394. 3.394.
positive 3.394.
That's what it is.
That is the value, and that matches what we got out of the graphical version. There we go.
Okay.
Nailed it.
Let's put these for viewers at home.
What's E?
Oh, forgot E.
Oh
Ah,
God,
E.
no.
Okay. No,
Wait, so how
no, E is gonna be easy.
Oh yeah, you just said.
Okay, so what we've done, we've confirmed D, we haven't done E. So what value of X yields a volume of 1120? Well, we go- we go back to the grapher, and we say, let's have another line, 1120. And where does volume equal to that? Oh, there are two values of X
That's killer.
that will give us that volume. And we'll use analyze graph intersection. There's one of them. Of course, I'd want to. Yeah, I guess 2, yeah.
Yes.
Dose.
I mean, it makes sense.
Right.
You don't really need
If it's an
to
asymptote,
sign here.
it makes sense that they're going to be on either side, right?
I'm not sure what asymptote.
I mean, not asymptote. I mean, sorry, if it's the parabola.
Oh,
That's not a
that's-
parabola.
Well, it's
not a
like
parabola.
trying
This
to
is
get
not-
one
this is
more.
a- this is-
I see
It's
the
a
parabola.
parabola.
This is a third order function.
It's parabola that's
Okay.
trying.
And then let me do the other one. Menu, analyze graph, intersection, low, high, and the other one's a beautiful 5.
Yes.
Yeah.
So those are lines you should find.
So does that mean the
I
other
was
one's
setting
not?
the volume equal to the volume equation, so that's what I did.
What was that?
This is way up.
Never mind.
All right,
This is so.
there we go. Now we got all the parts. We're not gonna do the rating to learn part.
Yay.
Sorry, I'm not supposed to say that.
Oh,